Back at Level 1 NCEA Earth, Space Scientists and Physicists, continuing on with the energy standard, today looking at the concept of electrical resistance. So electrical resistance is basically the opposition components have for the flow of electrons through them inside a circuit. And it's important to note that every component, including the lamps that we've been working with, have a resistance. Okay, so using the analogy of water, voltage is seen as the water pressure, current's the flow of the water, and resistance is kind of like blockages in the pipe which impede the current flow. So the equation for resistance is resistance equals voltage divided by current, where voltage is of course in volts, currents in amperes, and resistance is in ohms, that funny looking upside down U symbol. Okay, it's known as an ohm. And if you rearrange the formula, you can also get V equals current times resistance, or V equals IR, which is known as Ohm's law. So why are we doing this? Well, looking at resistances in different types of circuits can help you understand why we get certain brightness and dimness depending on the lamps, depending on the circuit. So for resistance in series, what we do is the total resistance of the series circuit is basically the sum of all the resistances. So what does that mean? For lamps, that means the resistance of one lamp plus the resistance of the second lamp plus the resistance of the third lamp all add up in a series circuit. So that means that the more bulbs you add, say like in Christmas lights, in a series circuit, the more the resistance increases, and that also means that the brightness of those light bulbs goes down because you've now got more resistance as you add more lamps. And then conversely, with parallel, so in a parallel circuit, each bulb has the same voltage across it. We already know that. So as you increase the number of bulbs, the total resistance of the circuit actually goes down. So this is the reason why when you place bulbs in parallel, they glow brighter. Okay, so in the previous example, the current was 1 amp, and as you can see, as the resistance goes down, the amount of current through our resistance equation goes up. So now you've got 4 amps going through the series, the parallel circuit, so the brightness of the bulbs increase.